Neutralization and titrations today, which is what your lab tomorrow. Lab tomorrow will be over that. So a neutralization reaction, just like the name assumes, is we're going to neutralize an acid and a base. Yep, and that will cross melt. Yep. Yeah. So we add an acid and a base together, and what you get as a product is the salt and water. And water is neutral, so it's a neutral, and salts do not have hydrogen or hydronium or hydroxide in them, so it's a neutral solution after you mix them together. So example here, we have hydrochloric acid plus sodium hydroxide yields sodium chloride and water. So it's always water, and it's basically a double displacement reaction where one of the products is going to be the salt and water. So we have hydrochloric acid plus calcium chloride gives us calcium chloride and water. So what would be our products for these reactions? Why AlCl3? Yep. Aluminum's 3 plus and chloride's minus 1. Plus H2O. Is it balanced? Then that's what we need to check next. No. So what do I need to do to balance this? I'd balance chlorine first. Put 3 here. So we have 3 oxygens and 6 hydrogens on this side. Right? So 3 waters. There you go. What about this next one? I'm going to put the products on the bottom. Ba you need to be able to write correct formulas. You'll have an ion chart if you need to look at it. How many oxygens do we have? We have 6, don't we? And 6 plus 6 hydrogens. So 12 hydrogens. Well, PO4 we can balance as a whole because we have PO4 here too. So we have 2 PO4s and 2 PO4s. So that balanced those oxygens out. So we just have to balance this oxygen.
We need a 6.
We need 6. Okay, questions on neutralizing a reaction? Okay, so titrations are all based on neutralization reactions. You're going to take a known, well, either the acid or base. You can do it. You can titrate both ways. You could have the base in the Erlenmeyer and the acid in the burette, but I think our lab will have the base in the burette. But you have a known volume and a known molarity of one or the other. And let's say you have the known volume and known molarity of the acid solution. And then you're going to add base until you get to the neutralization point, the equilibriance point. and you are going to then know how much base, you're going to measure how much base it takes to get to that point, so you know a known volume, and we'll be able to calculate then the molarity of that base. So we have an unknown concentration. So we do titrations if you don't know the concentration of one of the acid or base. We can titrate it in order to figure out what that concentration is. So a solution of accurately known concentration is gradually added to another solution of unknown concentration until the chemical reaction between the two solutions complete. That's called the equivalence point. And we use an indicator. We'll use phenolphthalein, but there's a lot of different indicators that change. They change pH, or they change colors at different pHs. And it all depends on if you're mixing a strong acid, strong base together, a weak acid, or a strong base together. It depends on if they're strong or weak, what pH that the neutralization point or equivalence point is at, and that determines what indicator you use. We're going to use a strong acid, strong base. So the equivalence point should be around 7, and phenolphthalein is a good indicator for that. But like in college chem, we've used brome crystal green. There's some other like methyl red, all kinds of different indicators. We will use phenolphthalein. So a strong acid-base titration looks like this. The pH would initially be very low if it's in the acid. And we keep adding base until eventually it just jumps right here at the equivalence point is where this vertical portion of the graph would be. And that's the pH, and then we're going to, pH is 7, halfway is the equivalence point, and then we have, if we keep adding more and more base, it becomes more and more basic. So we could use a pH sensor, and we could not use an indicator and find the equivalence point also and do the same calculation, but we're going to use an indicator and just measure volumes that way. Okay. So to do this type of calculation, you have, if we want to know the pH of a solution, never mind, this isn't necessarily quite right. So what we need to, well, I want to do a different type of problem first. This is just what a weak, so if you have a weak acid and strong base, the equivalence point is greater than 7, so that's why you'd use a different indicator, because the equivalence point's at a different pH. Here's a strong acid, weak base titration. The equivalence point is less than 7. Okay, this is what I want to go through first here. So to find the molarity of the unknown, so you have an unknown molarity of 1, and you need to use a known molarity of the other to calculate this. What you're going to do is write out the balanced equation, and it's a neutralization equation. You are going to, so our given, the sodium hydroxide, we know the concentration and we know the volume. We're going to calculate the moles of sodium hydroxide that's being reacted. What is molarity? Moles per liter. So we're going to need to get milliliters into liters. But we're going to calculate how many moles of sodium hydroxide we have and how many moles of hydrochloric acid are going to be needed to, it's a 1-to-1 ratio. We need to know how many moles of hydrochloric acid are needed to balance that. And then we know how much volume. So once we calculate how many moles, we can do moles per liter again and get a concentration. That's the step-by-step. So let's, they go by. I'm going to, here, let's get a new sheet. Can you give me the numbers for that? Of sodium hydroxide? 18.5. What was the concentration? big M, molarity.
Yeah.
And it was 10.0 milliliters, right?
Yep.
And we don't know the concentration. So it's saying it took 10 milliliters of hydrochloric acid to neutralize, to change the phenolphthalein from, if it was in a base, it would be pink to clear. So we need to figure out what the concentration is. So we need to know how many moles of sodium hydroxide is this. That's molar, though. And we need liters. How do I convert that into liters? There's 1,000 milliliters in a liter.
Yep.
So it's 0.0185 liters. And we need to find X. How many moles is that? It's going to be really small, isn't it? One, 4, 6, 2, 5. Now this one's simple because it's a 1-to-1 ratio. So we can have 1 mole of NaOH to 1 mole of HCl. Now, it's not always going to be 1-to-1. So that gives us 0.0041625 moles of HCl as well. And if I want to change that into molarity, I need to take moles divided by liters. So I want to divide by, what's my volume in liters? Just move it 2 decimals. So that's our answer. Questions on any of those steps? Okay. There are, let's do this problem. So sulfuric acid mixed with potassium hydroxide. Okay. What's our products? So is it balanced?
Nope.
No. Okay. And we have 2 liters or 2 milliliters? And I don't know any of the other numbers. Mil. Which concentration do we know? Moles? Molar? Molar, not moles. Okay. Okay. So whichever one you have both values for, you want to calculate the moles. So if 1.00 molar so it'd be the same, right? what was our next step? Yep. Y2 there? We use our coefficients. So we have 0.025. Oh wait, I don't know if we, I guess in the other one we didn't do that. How do we find, ooh, we know molar this time. Last time we needed to find concentration. So now what would we do? If you know the molarity, now we know moles. So we know moles is 0.025 moles over X amount of liters. So X is 125. 0.125.
That's liters,
So milliliters would be 12.5. Questions? So just a little different because they're asking for volume instead of molarity. Okay, we have one more. Why don't you guys start that one? You guys do that one. And I'll start working. I'll give you a head start. Phosphoric means that, what's the ion? What's the anion? Phosphate, and phosphate is what? PO4, 3 minus. Everyone have up to that step? What do I do next? Here you go. Everyone get that same answer? Yeah? We are not going to do buffers. Yeah. We don't have time.
We're not doing it at all?
Let's go back. Yeah, I think the rest of it's buffers, isn't it? Oh, we already talked about what we need to know about that. I don't know what that slide says, but yeah, we said that. We talked about that. You don't need to know the pH, that everything changes that, but just showing that each indicator changes at a different pH. Okay, let's do this one where we have two solutions. You know the volume and you know the concentration of each. And then we have to figure out the pH. It's sodium hydroxide and hydrochloric acid. Give me the numbers for sodium hydroxide. What? That was HCl? Molar. What about hydrochloric acid? Oh, the concentrations are the same? Okay. So, what we need to do, we need to figure out how many moles of each of these there are. Wait, I think that needs to go on the bottom. Oops. Oops, it's be 0.010 liters, right? So is that 0.001? Yep. And we do the same thing except for we have 25 milliliters, so it'd be 0.0025 moles of HCl, right? Well, this is 0.025 liters right here times 0.01 or 0.1. So like it's if I solved it already. Okay, so this ratio for this one is 1 to 1, right? So to be at the equivalence point, they should be equal number of moles, correct? Yes. So I have more acid than I have hydroxide, so we're actually going to have an acidic solution. It's not titrated to the equivalence point. It's more acidic right now. How much more acidic? How many more moles of hydrochloric acid do I have than sodium hydroxide? 1.5 moles of HCl. Okay, I'll put extra here so we remember that that's the extra we have. But when we take the negative log, we need concentration. So this is how much is non-reacted. This is how much, and it's since it's a strong acid and there's only one proton, it's going to only have one separation into chlorine and hydrogen, right? So that hydrogen is going to give it the pH. We need a concentration, though. So we would take moles divided by liters, and how many liters of solution do we have now? You add them together, right? We have a total of 35 milliliters, which means we have a total of 0.035 liters. Which gives us, that's our concentration. What is it? 0.43 molar. And then so to find pH, if this is our concentration, so this is actually equal to, so now we can take the negative log of the H plus, so our pH is, what was it? Right. If we would have had more hydroxide, we would have done it the same way. But when you did the negative log, it would have been POH. But you do the same process. It's just POH instead of pH, and then subtract it from 14. Does that make sense? Does anyone have questions on that? Okay. Yeah, but it's not going to be due till Friday.